The cosmos is vast and ever-changing, a tapestry of mysteries and wonders that stretches far beyond what our eyes can see. And sometimes it delivers surprises that challenge everything we thought we knew about our place in the universe. In 2017, the world watched in awe as Oumuamua, the first known interstellar visitor, passed through our solar system, an enigmatic cigar-shaped object that left scientists with more questions than answers. Just 2 years later, Comet Borisov followed, blazing a bright trail and confirming that our solar system is not isolated, but open to travelers from the stars. But on July 1, 2025, astronomers announced a discovery that eclipsed them both. 3/Atlas, the third interstellar object ever detected and by far the most spectacular. Unlike its predecessors, Atlas was astonishingly bright, its glowing tail visible to even modest telescopes while it was still far from the sun, sparking excitement among amateur and professional astronomers alike. Its arrival electrified the astronomical community. Here was a large active interstellar object, a rare messenger from another star system, offering a unique opportunity to study material from beyond our solar neighborhood. Atlas's incredible speed, 58 kilometers per second, meant it was just passing through on a hyperbolic path that would never see it return. A fleeting visitor on a one-way journey. This was no local asteroid. It was a genuine artifact from another solar system carrying secrets from a distant, unknown origin. For the first time, we had a detailed, observable piece of another world, large, active, and close enough to study in unprecedented detail, promising new insights into the chemistry and history of other planetary systems. The questions came quickly. Where did it come from? What cosmic events had shaped its journey across the galaxy? What was it made of? Could its composition reveal clues about the building blocks of planets around other stars? And as its behavior grew stranger, changing brightness, shedding material, and defying predictions, a new question emerged. What exactly was Atlas? Was it a typical comet or something entirely new to science? Its story was just beginning, and with it, a new chapter in our quest to understand the universe beyond our sun. Once 3/Atlas was identified, telescopes worldwide focused in. Astronomers everywhere were eager to catch a glimpse of this rare visitor from beyond our solar system. The excitement was palpable as scientists realized they were witnessing something truly extraordinary. And what they found was bizarre, even by cosmic standards. The data pouring in challenged everything they thought they knew about comets. Atlas was enormous with a nucleus nearly 3 kilometers wide, far larger than most comets we've observed. Its coma, the glowing cloud of gas and dust surrounding the nucleus, stretched almost the entire distance from Earth to the Moon, making it a truly colossal object in the night sky. Its outgassing was intense, spewing material into space at a rate that stunned researchers. But the chemistry was even stranger. Instead of the usual mix, Atlas had an overwhelming abundance of carbon dioxide with barely any water vapor detected at all. This was highly unusual for a comet. Most comets are icy, made primarily of water ice. But Atlas seemed to be composed mostly of dry ice, frozen carbon dioxide. This suggested it formed in a region of space so cold and distant from its parent star that water ice was rare, hinting at a birthplace in the farthest reaches of another solar system. Its tail was rich in nickel, but almost devoid of iron, a chemical signature that set it apart from nearly every other comet ever studied. This made Atlas a cosmic oddity, defying the standard models of comet formation and challenging our understanding of how these icy wanderers are built. But the biggest surprise was its behavior, something no one had predicted. Instead of chaotic jets, Atlas vented gas in precise rhythmic pulses perfectly synchronized with its rotation. Each burst of gas seemed to occur at exactly the same point in its spin, as if following a hidden schedule. The emissions seemed controlled, almost as if they were being directed by some internal mechanism rather than random outbursts. This non-random activity was so unusual that it began to resemble a form of propulsion, almost as if the comet was maneuvering itself through space. Astronomers were left with a puzzle. Was this just an incredible coincidence of natural processes? Or was there something more at play? Was this a natural process, or could it possibly be evidence of something artificial, something engineered? The evidence was mounting, and the mystery only deepened as more data came in. Every new observation raised more questions than answers. Atlas was unlike any comet we had ever seen. Its size, composition, and behavior set it apart from all others. Its secrets demanded closer scrutiny, and astronomers knew that unraveling the mystery of Atlas could change our understanding of the universe forever. Interstellar objects usually follow simple gravity-driven paths. But Atlas's trajectory was anything but ordinary. It was set for a grand tour of the inner solar system with close flybys of Mars, Venus, and even Jupiter. The odds of such a path by chance are astronomically low. Mars orbiters were quickly reprogrammed to observe the visitor, and the Juno spacecraft at Jupiter prepared for a possible encounter. This sequence of planetary flybys was so unlikely that it forced scientists to question whether Atlas's course was truly random. If you wanted to survey our solar system, this is exactly the route you'd take. Was this just cosmic coincidence or something intentional? The trajectory itself became part of the enigma. Atlas was not just a curiosity. It was a statistical anomaly that demanded explanation. Faced with so many anomalies, astronomers turned to artificial intelligence for answers. NASA's quantum AI analyzed every detail. Trajectory, chemistry, outgassing, planetary flybys, running trillions of simulations. The result? Less than a 5% chance that Atlas was a purely natural object. Over 95% of scenarios favored some form of controlled activity. The AI wasn't claiming aliens, but it concluded Atlas's behavior was statistically indistinguishable from guided propulsion. This was not proof, but it was powerful evidence that challenged our assumptions. The scientific debate was fierce. Was Atlas a new class of natural object or something else entirely, with only 3 interstellar objects ever observed? The sample size was tiny, but the AI's verdict was a flag, a signpost pointing to a mystery we could not ignore. The search for answers had never felt more urgent. While the debate raged, Atlas's presence was a stark reminder of our vulnerability to cosmic impacts. Atlas is enormous and fast. Its passage a wake-up call for planetary defense. We remember Chelyabinsk, a tiny asteroid undetected caused widespread damage in 2013. Atlas is over 100 times wider, with energy to trigger a global catastrophe if it struck Earth. Its arrival underscored the need to improve our detection and defense capabilities. Interstellar objects are harder to predict and arrive from unexpected directions. New observatories like Vera Rubin will help, but finding threats is only the first step. Atlas is a warning written in glowing gas and dust. The universe is not always benign. Our survival may depend on becoming true guardians of our planet. The mystery of Atlas was too compelling to leave to telescopes alone. Space agencies worldwide launched a race to catch the visitor before it vanished forever. Dr. Alan Stern's team proposed the Interstellar Comet Explorer, a rapid response probe to intercept Atlas near Jupiter. Such a mission could capture images and sample gases, potentially solving the mystery once and for all. NASA considered repurposing Juno for a distant flyby, and other spacecraft might pass through Atlas's tail. This urgency marked a new era. Missions must be fast, agile, and ready for the unexpected. The race to understand Atlas was a test of our ability to react to cosmic surprises. It was about more than one object. It was about our readiness to explore the unknown. The clock was ticking. In the end, Atlas is more than just a comet. It's a mirror reflecting our deepest questions and longings. Are we truly alone in this vast universe? Or is there something or someone out there watching with us? Atlas invites us to wonder, to dream, and to confront the unknown with curiosity and awe. Is the universe filled only with rocks, gas, and silent emptiness? Or does it harbor other forms of intelligence, perhaps even civilizations as curious as our own? Each discovery pushes us to expand our imagination. If Atlas is a natural wanderer, it reminds us how little we truly know about the diversity and complexity of worlds beyond our own. Every new object challenges our understanding and reveals the universe's endless surprises. But if it's not, if we're witnessing a probe from another civilization, the implications are staggering, opening doors to possibilities we've only imagined in science fiction. It could be a silent observer, a derelict relic, or even a messenger, tangible proof that life has arisen elsewhere and that we are not alone in the cosmos. Either way, Atlas has pushed the boundaries of science, inspiring new research and uniting us in a shared sense of wonder and possibility. It reminds us to look up, to question what we know, and to work together as a global community in pursuit of answers. The story of Atlas is not just about a comet. It's about us, our curiosity, and our relentless drive to explore. It's about our response to mystery, our willingness to embrace the unknown, and what that reveals about the very nature of humanity. As we stand on the edge of a galactic future, Atlas challenges us to reach further, to dream bigger, and to never stop searching for answers. The journey has only just begun, and the universe is waiting for us to discover its secrets.